Alright, we're beginning here. I'm going to right away start by erasing what we've got, and we'll see how much we can erase. I'd like to erase everything but the, I'm kind of going through here. I'd like to keep the reactions around, so I'm going to erase all this stuff out here. And we're going to solve for the members right here, 9, 5, and 2. And so, in effect, when we do this, we realize, I'll go ahead and write my 3621 and my 4328 down. So I know, even though I won't need them, I've got a reaction in this direction of 4328 and a reaction in this direction of 3621. And we also then have a reaction here which has to react to that 707 going up. And the reason why we can't have any reaction here is you see this member is just like that. So that said, I'll erase out the rest of it. And we'll get on with the rest of the problem, which is really what method of sections is all about. It's about being able to cut the structure through any three members, because you know the lines of force. You know the lines of force are along the axis of this truss members. That's one of the assumptions in a truss. Remember, the other assumptions that you apply your loads only at the joints, as you see here, or at the nodes. And then, of course, that you need to keep track of whether it is statically determinate, whether there is redundancy, basing on the number of equations versus the number of unknowns, realizing every joint gives you two equations. Plus the ones you have then at the reaction. So what we're going to do here is we'll go back to the pens and we'll see how quick it is to go ahead and cut a section out here. And I'll sketch it down below. When we cut that section, we have a force going this way. We're going to call the tension in force 9. We have a tension going this way. We're going to call the tension in member 5. And we have a tension going this way. It's the tension in number 2. Now we know, looking at this, that number 2 is going to be in compression and number 9 is going to be in tension. But we don't have to make that assumption. What we're going to do is we're going to write right now, we're going to solve for number 9 by doing the sum of the moments about this point. And we look at the sum of the moments about point 2, and we realize that 5 and 2 both go through this, so they're both going to fall out. So we have, starting with this tension, we say the tension in 9, and it is going to the left, so it is causing it to spin positively, and it is 3 away according to moment arm. In other words, this distance up here is 3. So we've got that one. We then also have 500 spinning 3 feet away, or 3 meters away. And that, of course, is spinning negatively. And so this, of course, has to react to this with 500. Realize this 500 out here, we don't see that. We don't see any of this because we're cutting the structure right through here. Even though we're using some of the moments here, we're looking right as we go through here. We can cut that anywhere we want. But we can realize here that this is going to have to be, obviously, 500 to resist that. And then we also have minus, once again, the 707 times 6, because we're 6 meters away. And then we also, in addition to that, we have also spinning in a negative direction, 707 times 3. And in effect, what you see is this has got to resist right down that plane. So what we end up in effect is 500 plus 2 times 709 plus the addition, 707 plus the addition of 707 just to resist this. Remember, this has two components here. And so we have the tension in 9 is going to be equal to, when we solve this out, 500 plus 3 times 707, and that is going to be equal to, if I go down here, I'm kind of pulling this up here, 707 times 3 plus 500, and we have that equal to 2621. So right inside this member here, right in there, tension in 9 equals 2621. And we know that is, in fact, it is tension. Now what do we have? Well, in effect, we could solve the rest of this by just adding up the sums of forces and realizing we have two unknown forces of known direction. So we could do some of the forces, but instead let's not do that. Let's go ahead and now do the sum of the moments, in effect, one more time, but this time we're going to write them about 0.6. So I'm going to go ahead and erase this out. We have the 2621 in tension. I'll take out my eraser, and I'll write sum of the moments about 0.6. And doing that, the sum of the moments about 0.6 were right here. Again, even though we're cutting it there, we're summing the moments about 0.6. This 500 falls out. What do we have now? Well, we have, once again, we have the 707 spinning in a negative direction 3 meters away. This one here does not, this one goes all the way through that, so that's the only spin we have on here. The only spin we have on here, if we think about the forces that are on here, right, if we're spinning about this point, all we have is the 707 at 3, which means in effect we're being 3 meters away, right? This one, if we're going about this point, this has no torque about that. So what you're going to do is here you're going to have this having to be, in effect, we're going to show it in tension. That tension is showing it as negative. Negative tension in 2 times 3. And of course, when you solve that, you realize that it's going to turn out to be negative. And so you have, in effect, we have the tension in 2 equal to 707 in compression. And that, I would say, would tend to think, you tend to think that kind of odd. You tend to think that you would have something a little bit larger than 707 in compression here. But so what we have so far at that section is we have 2621 that way. We have in compression, we have 707, which means in effect we also are going to have a lot of compression coming this way. And so when we solve all that out, there's all kinds of different things you can do, but in effect your best bet then at this point in time is to just to do a sum of the forces. And so let's add those vectors. If we look at this here, we know that we have on this section as it's cut, we start with 500 down, right? We then have 1,000 in this direction. We then have 2621 going right across that way. And then we have 707 going back. And what we have to realize is right there, it should be exactly the same direction as is this truss. So it should be up at 45 degrees. So once again, we can do them by tables. And with these minutes, I will just assemble the table in the components, and we'll come up with the components of number 5 and make sure that they're one-to-one. So I'll do that with it's paused. Okay, we've done this math, and what we've added up here are the sums of the components of the forces except for number 5. Realize that number 5 has to bring it all back to 0. It has to react to everything around it. And so in the end, we see that this turns out to be, this is actually a negative value and a negative value, which means you need to have a positive x and a positive y. I want to point out here that 1207 and 1207 prove that this is a 45 degree. And so when you end up is the square root for the magnitude of that is the square root of 1207 squared times 2. So that's plus that, 1207 squared, and that's what your last stress is in that one. And so that's how you go about doing some of the moments, method of sections. It's really pretty straightforward. Remember, you can pick any three members, and it doesn't have to be straight. You can cut across here, and then you would basically be having your three unknowns that way. You should show your unknowns in tension, and you should learn to start doing it just by guessing and reaction, but then what you're doing is you're solving with the sum of moments about 1. That gives you the forces in the member that is somehow disjoint from that. Thanks for listening.